In this video, I'm going to be talking about how to do some basic statistics with R. So this is really more for beginners. And I'm also going to be using a couple of different packages that you'll need to install, and I'll show you how to do that in this video. So I'm going to be showing you how to do some of these things in base R as well as with these packages that can make things a little bit easier, or just make things appear nicer looking and more presentable. So take a minute and look at the packages on the next screen, and then we'll get started. All right, so basics with R. So first of all, this little hashtag symbol that you'll see when you open up RStudio um, is a way to put in a comment. So this is the way that R knows you're not trying to run some kind of function or compute something. So we're going to do some importing data, some descriptive statistics, and then show a little bit of plots. So first of all, when you open RStudio for the first time, it's not going to quite look the way that it does here. I have changed the settings to give it a black background and changed the color scheme a little bit. This is just to make it easier on my eyes as I look at it a lot. And on in the console section, you're going to see the version of R that you're running. Make sure that you have the most up-to-date version of R. And then this section where you can type things in, that's called the source here. You can put notes in here. This is an R script section, and you can save these files, and then they can be reopened later, and it makes it easier for keeping track of what you're doing, and also keeping track of things you're doing that don't work to help you remember later. All right, so some packages that we'll use. You'll see the packages down here, Rio, Psych, and ggplot2, but you need to install them if you've never used them. And to do that, just start typing install, and you'll see install.packages pop up. You can either press tab or click on it. And then the way to install the package is to put the name of the package in quotation marks. So you'll need to put Rio there. To run this, you can either click run, which runs whatever, and it will even tell you here, run the current line or selection. So whatever you've highlighted or the current line that you're on, you can click that, or you can press Command Enter or Control Enter, depending on if you're using a Mac or a PC. I already have these packages installed, but you will need to do this in order to, for each of the three packages, in order to make sure that you have them installed. And then you need to load them so that in this R script, as you load them, it knows like, oh yeah, these are another set of functions that are available to use to compute things or to plot things. So we do that by using the function library. So type library, and we don't need quotation marks this time. So we're going to load library Rio. Remember to click run or command or control enter. This is for easier importing and exporting of data files. It makes it easy because you don't have to know what kind of file that you're importing, and I'll show you in a minute. Library psych. There is a function in the psych package. The psych package is really big. There's a lot of things in there. We're only going to use one function, which will help us get a bigger view of the descriptive information all at once instead of having to do them separately, as in base R. Base R does do some things automatically, but we can expand that selection here. And then ggplot2. This is to get better plots, nicer looking plots. I also have a video called Making Pretty Plots and Tables that you can watch, and I go more into depth about how to make some changes than I will in this video. All right, so once you've loaded these packages, then we need to set the location to import the files from. So in this video, I'm going to use the raisins data as I have in a previous video. But first, you need the file path that goes to the folder where the data is stored. And this file path is also where you can save the R script file using the save button up here. So first, set WD is the function that you want to use first. And this is telling R, look in this folder every time I import something, every time I export something or save something, do it into this folder. So you need the full path that goes that folder. If you are using a Mac, if you right click on the file that you want to use and click Get Info, you can copy the file path from that image or from the little window that pops up. And then we need to import the data file. So using base R here is the read.csv function. So we have to know what kind of file extension it has in order to import it using base R. So it is a .csv file, and notice that I'm just putting the name of the file because the file path is already here. So once you've run this piece of code, setwd, it will know to find this file located in the folder that this path goes to in the setwd function. And so you need to put that in quotation marks as well. And then this little backwards arrow looking thing, so the less than symbol and a hyphen, is telling it to store this file into the letter D. So the letter D is going to hold our file, our data. So letter D for data. And so when you run that, and let me initialize these here. You'll see on the right side where you're importing or where the code is actually being run as you press Command Enter or run, that this little symbol pops up at the bottom, greater than symbol, and that is telling you that it ran this code and it's done. And there's no errors, otherwise it would tell you there's errors involved. Or warnings of some kind will pop up there sometimes. And if you don't see the next little greater than symbol, then that means it's still running. And usually that means that somewhere, maybe in the top right of the corner, there will be like a little stop sign. That's telling you that it's running, and you can click on that to stop it from finishing. If it's doing something really complicated, sometimes it takes a while for it to stop. Okay, so that's how you do it in base R. And like I said, you have to know the file type. So depending on the file type, base R can only handle so many different types. That's why I like using Rio package. Because there's only one line that you need to remember, and that is the word import. So, and you'll notice as you start typing it, it pops up here and it tells you it's from Rio. That's what you want. And then you can just copy and paste that in there, but it will automatically know. And I got an extra set of parentheses here on accident. It will automatically know what type of file it is and how to import it based on that type of file. So this import function will import Excel spreadsheet documents. And then there's things you can add to the function if there's multiple worksheets, multiple tabs at the bottom, so you can tell it which tab you want. Otherwise, it just pulls the first one. It can import files from SAS, from SPSS, all kinds of different types of files. It can import a .dat file, a text file, all kinds of things. So it's really kind of just a catch-all function where you don't have to remember what the specific file is. You just use import. So that will import the data the same exact way. I've already got it imported, so I'm not going to import it again. And so let's say we want to look at some information about this. So first of all, we need to do a little bit of checking the data. So the first thing that you might want to do is say, well, did it actually import it correctly? You could just click on the little D down here at the bottom in this where it says environment here. As D, it tells us there's 70 observations and 2 variables. And I know that there's 2 variables in this data set, actual number of raisins and predicted number of raisins. And so if you click on that, it will open it in a tab and it will show you what it looks like. And you kind of check through and look and say, oh yeah, that looks right. And it filled in NAs here because there actually wasn't data, and these two things aren't connected to one another, right? So like the person who opened a box that had 34 didn't predict 28 for that box. So there's no link here. We're just have two different variables. They're disconnected from each other. Um, so it filled it in with NAs, which is helpful whenever they are connected to each other. All right, I'm going to close that. And some other things you can do. So the names function is the first one here that pops up. And notice it says functions to get or set the names of an object. So we can check the names of D, which tells us the names of the columns or the variable names or the attribute names. So here after you run that, it shows us on the R console side, actual and predicted are the names of the columns. And notice they're in capital letters. So that will need to be the way that we call those variables later. Another thing we can do is look at the structure of these. So str of D, I'm just going to show you what it does. It tells us that the variable actual is an integer variable, and the predicted variable is also an integer. And so we want these to be numeric in order to do statistics with them. So sometimes things will be in a character, or which means that they are text rather than numbers. Sometimes even though they might be numbers, when you import them, it imports them as text. So you have to reformat those to tell it that it's a number so that you can run the statistics with it. Sometimes it'll import it as a factor variable, which is like a grouping variable. And so we can talk about that in other videos, of course, but it's a nice way to see what it looks like. And you can kind of get a little preview of the data here in the console side. Okay, and these dollar symbols are important too. The dollar symbol is how we tell R what specific variable we're wanting to look at. So let's look at descriptive statistics, and I can show you what I mean. So using base R, there is a function called summary, and this gives us multiple descriptive statistics at once instead of having to call them multiple times. So it gives us the minimum, the first quartile, like of a box plot, so 25% of the data is below of less than 32. The median, the 50th percentile, the mean, the third quartile or the 75th percentile, and the maximum, and also tells us how many missing values there are. Although in this case we don't care, those aren't really missing values, they just are simply things that don't exist to begin with. And of course we could run some of these things ourselves. Like if you notice that there's no measure of spread here, these are you could calculate, for instance, the IQR by looking at these. There's ways to call that in R. We could grab the standard deviation of the variables here, standard deviation of D. Notice that whenever I type that, it doesn't give it to me like it did with the summary. It says error, list object cannot be coerced. So what it's telling us is you didn't tell me which variable you want. So the standard deviation function is not built to handle that. So we have to tell it which variable we want. So type the $sign. It will start to show you what variables you have as you start typing. Make sure that it's the actual or the specific way that it's written. It is case sensitive. So you can press tab or click on the word actual. And look what happens when we do this. Remember that there's 29 missing values here. So when I try to run this, it's going to give me NA because it doesn't know how to compute something with NA because we didn't tell it what to do with those NAs. So it's trying to keep it in there. So we need to use a function called na.rm, which means NA remove. And notice it gives us this little help window, should missing values be removed. So I'm going to click on this. It just goes ahead and finishes putting the equal sign and type in true. So NA remove, should NAs be removed? True, yes. And then once we do that, it will tell us the standard deviation of the variable actual number of raisins. But it doesn't show that to us in the summary. The summary is more of just giving us a basic picture of the box plot as well as the mean. Um, the describe function is better at this. And when we use the describe function, that's from the psych package. So you have to have the psych package loaded in order to do this. So whenever I run that, notice it automatically knows what to do with the NAs. It automatically drops them by default using this function. And of course, it's cutting it off at one decimal point here, so we can add in things to the function if you want to expand that and show more decimal places. But it gives us a lot more, so it doesn't even fit on one screen here. The table keeps going on to 3 rows, but we have the number of non-missing values for each variable, the mean of each variable, the standard deviation, the median, the trimmed mean, the mean absolute deviation, which is a different way of talking about spread similar to the standard deviation, but instead of square roots in the formula, they're using an absolute value. Some people trust this one a little bit more, but notice it's really similar to the standard deviation. Whereas with predicted, it's much different than the standard deviation here. The minimum, the maximum, the range, and skewness and kurtosis values. So skewness is how different it is from being perfectly symmetric, and kurtosis is peakedness. So a positive value means that there's a really tall peak, and values less than 0 mean that it's sort of squashed down flatter from what a normal model would look like. And then this is the standard error on those skewness and kurtosis values, which I'm not going to talk about in this video. Okay, so it gives us a lot more information. It's really helpful to see that information, and we don't have to sort of add things. This is sort of like the bread and butter of looking at descriptive statistics for most statisticians or social scientists. Okay, so then plotting using base R. So the first thing that we might want to do is, well, first we'd want to pick which one we wanted to look at, but maybe we want to look at a histogram first. So if you start typing histogram, you'll notice it comes up here as HIST. So you can just put histogram D, and we need to tell it which variable we want to look at. So let's say we want to look at actual. We can run this just like this, and it will show up down here in this plot window. And you'll notice that the title and things like that may be things you want to eventually change, because it's using the R code here at the top, D $actual. If you're presenting this somewhere, you probably want to clean that up to make it more clear what you're looking at to people who don't use R maybe, or if you have variable names that aren't that are a little bit difficult to decode what they mean. We could also look at a histogram of the predicted. And you can see that it's highly skewed, as we could tell here. The skew value is 2.47. In general, we want skewness to be within plus or minus 2, as well as kurtosis. So it's pretty highly skewed, and with what looks like an outlier on the far right. We could also look at a box plot. And by default, let's say if we look at actual, by default, box plots are printed vertically rather than horizontally. So if you wanted to do that horizontally, if you're used to seeing it that way, what you need to do is add a piece to this. Horizontal equals true. By default, horizontal is false, and it will flip it the other way if you want to look at it that way. All right. And we could, of course, repeat this for predicted and look at these. And there's also a function called par that allows you to print multiple plots in the same window. I'm not going to talk about that in this video, but it is possible to do that. And of course, it's possible to change a lot of things and add titles, add labels, and things like that using base R. But I would rather spend my time talking about how to do this in ggplot, because ggplot has a lot more functionality in being able to make things look the way that you want them to. So to do the same thing using ggplot, and remember you have to load that using library function that we did at the beginning of the video. So first thing you type is ggplot. That's the function we want. And the first thing that goes in here is the data set you're going to be plotting variables from. So we type in the letter D. And then ggplot works by adding layers of aesthetics to the graph. So AES means aesthetics. And what we want to tell it here in this first line of the code is what X and Y are. And you can see that showing up there as a help if you're just sitting here. It says X, comma, Y, comma, dot, dot, dot. So there's other things you can add in here. But for now, we're just going to tell it what the variable is that we want to plot. So I'm going to start by saying X equals actual. And you have to type it in all caps like the name of the actual variable is. That's in D. Okay, so that's all we need to put here for now. And then we're going to use a series of lines with a plus symbol at the end. So we're going to add these different layers. So now we need to tell it what to do. So we've told it what variable that we want. Now we need to tell it what to do with that variable, how to represent it. So to do a histogram, we want to do geom histogram. And as you start typing it, of course, you'll see it pop up here. And we could just stop here. And if we stop here and we run this, and if you just put, you can have the cursor anywhere in here, you'll notice that it indented this line here. It knows that this line is connected to the previous one because of the plus symbol. So anywhere in here, you can have the cursor and you can press Command Enter or Control Enter, and it will run all the lines of code. Okay, and it looks like this. Well, that's not how we want it to look, right? The bin widths are a little bit too small, so they need to be wider so that they're touching. And you'll notice here it gives us some information about what it did. It said stat bin using bins equals 30. So it was pretending like there would be 30 different bins, which maybe is a little bit too big for the actual variable. And then it says pick better bin width with bin width. So it's telling us, and then it gives us a warning message. Removed 29 rows containing non-finite values. These are the 29 missing values. So we don't care that it dropped those. Those were NAs. That's perfectly fine. We wanted it to do that. We don't want to plot the NAs. So we can change the bin width here. So if we type bin width in the histogram function piece, bin width equals 1. And we run that. And then it looks more like this. And this is looking closer to what we want. But you'll notice now that it looks a little strange because there's no outline on the bars. So we can add that. So to keep this all on the screen here, I'm going to put a comma and just press enter, and it will indent the next line so that it knows this is part of the geom histogram function. And we can tell it to make the color black. This is color in this function means the outline. And then maybe the fill of the histogram can be white. And if we do that, then you'll notice that it looks a lot better now. And then another thing that I like to add to this, just to make it clean it up a little bit, because the gray background can sometimes be annoying, or if you need to print this somewhere, you don't want to print the gray background. So there is a function called theme _ black white. You'll see that here. And you don't need to actually put anything in there, just and make sure you put a plus sign at the end of the previous line and type theme black white, and then it will clean that up in the background for us. So now this is looking a little better. We could, of course, change the color of anything we wanted here. There's lots of different colors. If you just Google ggplot colors, you'll see a list of what the names are of different colors that you could type in here to make it look how you want. So now we have the histogram in here. We could also add to this a box plot, or we could do a box plot all on its own. So to do a box plot all on its own, we would want to start out in exactly the same way as we did before, except this time we're going to use geom _ boxplot. So it looks really similar. And when we run this, notice we get the same warning message. 29 rows containing non-finite values, whatever, it's fine. Okay, and then here's what it looks like. And of course we could add to this the black and white theme, which will remove the background gray color and make it white. And now we have that. We could, there's lots of different things we could add. If we wanted to make the box plot overlaid onto the histogram, we could also do that. And if you watch my video called Making Pretty Plots and Tables, I talk about how to do that. You basically just add the geom boxplot function to the histogram, or to the one with the histogram. But then you also need to include some other things in order to correctly size the box plot on the screen and locate it in a place where it's not covering up information from the histogram, and so that you can see how it looks. So you can do that. I also show how to do this in the video where I talk about recreating plots from CodeApp in R. Okay, so there you can do that. If we want to add a title to this, then we can add different titles by using the function. Whoops. Labs, and then we can say title equals, and here for the box plot we could say box plot of actual number of raisins. And notice it adds it here like this, where it's not actually centered. And you can actually go and watch my other videos to see how to center that. In particular, the one maybe that's the easiest to skip through is the CodeApp video, how to recreate graphs from CodeApp in R. I show how to do that and show all of the code there to relabel everything and make it look nice. But this is something that you can add these different layers using the plus symbol and make it look how you want it to. So I hope that you found this video helpful, and let me know how you're thinking about this.